So, hello everyone. I'm Elias. I'm the tech lead for the Linaro Edge and Edge working group. We mostly focus on firmware nowadays. We also do some edge work, but our main focus is firmware and firmware security. Before we start this, out of curiosity, how many of you have worked with EFI or know what EFI is? Congratulations on a terrible career choice. So, any of you having been involved with SystemReady IR or certification? Yeah. Second, congratulations on the same terrible career choice. So, what's SystemReady IR? John summed up this way better than I did. It's basically a band of the SystemReady certification program. You have multiple bands. You have server ready, embedded server ready. We're focusing on the IR, which is the IoT embedded ready. And it's backed by some ARM specifications. There's BSA, there's EBBR, there's BBSR for the security. There's a few ARM standards that are backing up the SystemReady IR, which is basically a collection of standards you have to adhere to. What it tries to do, in essence, is that it tries to define a minimum of software and hardware characteristics that you can, and get an assurance from the firmware that you can deploy an OS and minimize your engineering effort while doing so. And for doing that, it's obviously using EFI interfaces. So that's a bit of a history. So basic EFI support, very basic EFI support was merged in U-boot back in 2016. That was very rudimentary back then. We just managed to, boot applications and play around. There has been a long development effort since then. Around 2009, we gathered up in Bangkok on Linaro Connect and we tried to figure out the missing bits and pieces. And back then, we figured out that U-boot had very basic EFI variable support. In fact, the EFI variables were stored in the environment. The EFI boot manager was just merged a few months ago. There was no UEFI secure boot, no measured boot, no capsule updates. Not major, but some of the protocols that the kernel relies on nowadays for its own security, like the EFI RNG protocol, was missing. A full implementation of the EFI boot manager. Generally speaking, it was working for proof of concepts and demonstrating that this could be doable on U-boot, but it was nowhere near a product ready or a stack. So my team started working on this. This is, again, a summary of approximately when the features were added and when did we get the compliance. So the first thing, I think this is not in priority order or historical order. This is just random dates I picked up from the Git commits. So EFI variable storage, it's supported in both replay protected memory block device and in a file. Those were approximately added on the same time period with a month apart. UEFI secure boot followed up the moment we got EFI variables working. And shortly after, we did the EFI measured boot support for the TCG specs. Capsule update was merged around the same time, but it was only the initial capsule update support. We didn't have any authentication back then. That was added a few months, 2-3 months later, something like that. One of the latest additions is that we didn't support set variable at runtime. And when we initially drafted EBBR, we didn't think set variable was going to be a huge deal. But it turned out it was a bigger deal than we initially anticipated. In hindsight, we should have requested better support for it anyway. The patches got merged fairly recently about set variable at runtime. We do need some help from the operating system to complete the procedure, but they're going to be included in the next U-boot release. So 2024-07 is going to have set variable at runtime support. And set variable at runtime is... maybe most of you don't know that, but you can store variables in U-boot. You can either store them on a file or in an RPMB. The RPMB case offers you all the security you need. You can read, write variables. You can edit them. You can do whatever you want with them. And the set variable at runtime has been supported on that variant for almost a year. On top of that, and these are things that are not mandated by SystemReady. We have, on certain hardware, we have multi-bank firmware update. So when you update your firmware on the field, you want to make sure that you won't break the device you're updating. You want to make sure that the update goes through. If the power goes down, you still get a usable device you can update. So we do have support for that, and this has been merged into U-Boot. It's backed by a standard Linaro and ARM wrote together, and there's also a document hosted in Linaro which explains exactly how this should be implemented. And there's a reference implementation in U-Boot about 2 platforms, I think. Is it 2? Yeah. There's EFI boot manager enhancements. We keep adding support into the boot manager to make it feature-rich and try to at least do all the features from the EFI spec that make sense. We now have EFI HTTP boot support, and HTTPS is work in progress. We have the EFI RNG protocol support, which is, again, needed for KSLR and other security things on the kernel we need it for. And there's many more coming, right? There's a set of patches right now in U-Boot enabling a different TCP/IP stack, so you get a fuller, rich TCP/IP stack. There's another RFC that changes the way we do crypto operations in U-Boot, and instead of doing them in U-Boot, we try to use embed TLS. Those haven't been merged. Those are discussed openly right now, but we hope they're going to be merged by the end of the year. So that's enough of the U-Boot history. Let's go through the system-ready requirements in brief, right? What do you need to get your board certified? First of all, the IR bond needs a UEFI-compliant bootloader that needs device-free support, right? If you're not interested in device-free, you should be looking at other bonds. You need some basic sanity testing from the EFI cell, which needs to be done manually. And you also have to perform capsule updates manually. There's an architecture compliance suite. It's basically a huge set of EFI applications that test your implementation. And once the EFI application is done testing, there's a very small Linux distro that runs afterwards that does extra testing for things that we're going to discuss later down the presentation. The ACS test is automated, right? So it's basically an image you write on a USB flash or somewhere on your board, you plug it in, it boots up and spits out the results a few hours later. You need to install 3 distros. This is obviously manual, and this is kind of a pain point, which we'll discuss later on as well. You can optionally run tests for the security interface. So there's another set of tests which runs tests against UEFI, the EFI secure boot implementation, and the EFI measured boot implementation. You need to create a log with all those information, and you need to send the logs to ARM, first of all, and then before you do that, verify those logs with a set of scripts that ARM provides. That gives you a summary of whether the test succeeded, if you have problems, and if you do have, what are those problems. You can find a complete link. Actually, the ARM page for the explanation of what you need to do for system-ready compliance is quite thorough. There's a link there for anyone that needs it. So what U-Boot does, it's been stable for a couple of years. Well, we hope it's stable at least. The first release that was system-ready compliant was 2021-04, and I think that's the majority of the version that board vendors use to certify their boards. ARM keeps a nice list of officially certified boards, and the majority of the certification was done against 1.0, 1.1, the earlier versions of system-ready. There's some significant differences compared to 2.0 that is required today because 1.0, it is deprecated, right? You don't... Yeah. So the major differences through 1.0 is that you now need authenticated capsule updates. There's some tests on device tree that are running, and you need to prove that your device tree is conformant and compliant to the DT schema validation tests and not something that you created on your own. There's some tests on the block device and how many devices you're using. Basically, ARM is trying, and there's tests on the Ethernet interface as well. I think that what ARM is basically trying to do is that if you pass the system-ready certification, they try to make sure that your board is usable on at least the very basic interfaces. You have, block devices, you can install the OS. You have an Ethernet that you can use to download and packages and play around with the board. and there's optional. This was included in 1.0 as well. It was just a different procedure. Now you get a nice menu entry when you boot up, when you can run your SIE, the security interface extension tests. So common issues. I want to thank ARM here for helping me compile the list because I wasn't aware of all the problems, obviously. I just knew the basics. And again, these are not in priority order. Vincent, I don't know, you can comment on the priority with what's more common or not, but this is a random list compiled by me. So the first problem is capsule updates. Code missing from the firmware, right? The capsule update implementation is board specific. I mean, if you look at the EFI spec, it's kind of board specific. We have a nice abstraction in U-boot, but you need to define some things for your own board, like the GUIDs of the board or what flashes are you updating. Apparently, people missed that, right? And they don't even support capsule updates. The second problem is the device tree validation, which, remember, it got introduced in 2.0, so it wasn't there in 1.0. There's some things that might help. There is a new config option in U-boot, which is called config of upstream, where you can basically ignore the device tree we compile U-boot with, and you can pick the kernel one, which we know is compliant because the device tree isn't, I mean, it's maintained in the kernel. Arguably, it could be moved around, but that's where the official repo is. So maybe that helps. Another point is distro installers. SystemReady requires 3, and even if you do a perfect job and you upstream all your drivers and your board is well supported in the kernel, that doesn't automatically mean that distros will pick up the support and compile the modules you need. I honestly don't know how to fix that. We need to be able to, first of all, we need to convince board vendors to upstream at least the modules they need to boot up their boards, and then they need to talk to distros to have them ready before they try to certify a board. Reset from U-boot doesn't work properly. I don't even know how they managed to do that. Missing ESP, that's kind of a side effect because when U-boot stores the variables on a file, it needs an ESP. Most of these are configuration issues, right? You have, for example, you have precompiled boot arguments that don't allow SIM to boot, so distros don't boot. You have environmental variables stored in U-boot in the same medium that you try to install your OS. So when you install your OS, you either override your U-boot boot arguments or you need to have protective partitions and do special configuration in the medium. They managed to miscompile U-boot. Again, the variables can either be stored on a file or on a special device. So they managed to choose that they want to store the variables on an RPMB, and the board doesn't even have an RPMB. And there's USB issues, but yeah, those are driver issues, and I don't know how often you see those in U-boot.
It's revealed by the 5 hours SCT run. So I think it's not common for U-boot to be tested during 5 hours for USB access, and this is what SCT is doing, so it's revealing those problems.
Yeah. Thanks. I don't know if anyone, you can interrupt me at any point in time if you want, yeah.
Speaking of broken things, I had a board which supported storing variables in Flash, but forgot to enable all support for all versions of Flash chips they used.
Yeah, it's with regards to the previous slide, how the distros. I would say that one of the things we see actually is not about the testing itself, it's about the behavior, which is broken. So we see vendors trying to certify at the end of the journey. Actually, so they get the firmware. Okay, I have a candidate. I'm gonna certify. SystemReady should be a designed input. That should be by design. So then you don't have to check that at the end of the process. You should be able to do it while you are doing the process. Actually, that's something that also needs to be changed.
Yeah, one of the slides. I mean, one of the previous presentations, we are talking about device. Yeah, stay there. Device tree to be kept as part of firmware, and now you're talking about moving it to OS because you want to certify it.
Yeah, okay, you're right. No, I'm not. I'm not arguing to move it as part of the OS. There's a config option in U-boot where you can use the device tree that's upstreamed in the kernel instead of using the one we define in U-boot. So it's still the firmware that provides it. In that case, what changes is where you pick up your device tree. If the one U-boot has is old or has undocumented nodes or doesn't work with the DT validation tests, you can configure U-boot to compile with the device trees you find on the kernel, which are guaranteed to be compliant.
So the problem is, so U-boot have a different version of device tree. OS would have different version of device tree, and both are consumer of a device tree. So many times, firmware has the device tree, everybody is consuming it, and if the version is different, what's the point of compliance? Like the firmware is not compliant, but OS is.
I know. I think this is a very nice topic, but I think we should discuss it in the context of John's discussion, of John's presentation on OS installations. So yeah, the question is now, U-boot is quite stable. I know. I mean, we test it regularly for SystemReady. We do try to test it before every release. We know that since 2021-04, I think I broke it once. Non-functional problem. It's just a test problem. The question I have for ODMs and OEMs and perhaps people out there is, why isn't this adopted? Do you think it's a bad idea? Do you think it's hard to move to EFI? Do you see any problems by moving to EFI? Is there, functionality that you had on your boards and by moving to EFI you lose that, and customers say just don't go there? What would be? Are there any missing features? And if there are, which are those features? Maybe we can fix them. My question is, why don't we see this more on BSPs? Because from a developer point of view, it's substantially easier to boot an EFI distro rather than going around poking, random registers and memory permissions and whatever we used to do in U-boot. So, any thoughts? Anyone has a feedback of why isn't this adopted, or why don't customers want it more? And is anyone aware of any products that use SystemReady?
So you're asking the question to the ODMs and OEMs, and I'm wondering if their answer is going to be, because that's what the SIP provider does. Okay, in which case you need to be asking the SIP providers. And so if you ask me, I think that this is just a transition. So the way that an OS is booted, they got it worked out through other mechanisms in EFI, and it works. They don't want to touch it, right? And so this is just taking time.
Okay. Yeah, the reason I haven't included SIPs is that in my imagination, at least, or how I think the world is working, is that ODMs come to SIPs and say, we want this, and then SIPs add it. They don't take the initiative to add it. But yeah, if you think that's a transition period, that's encouraging, right? Because I really think we're on the right path here as far as the whole booting process is concerned.
Yeah, I think I'd reinforce what John says about the OEMs and ODMs. They want to copy what the SIP provider does. And when I'm consulting with people, that's exactly what I'll advise them to do, because it's the best tested. It means you won't tickle a bug in the thing that hasn't been tested before by the SIP. So yeah, it's not just not wanting, it's that they want to stay where the testing's been.
Yeah. We have another one.
I have non-technical question. How much does ER certification costs?
I can't comment on that.
Okay, it's like, is it 4 digits, 5 digits? This kind, right?
I obviously can't answer that. If anyone from ARM wants to take that, I'll be happy to hand over a microphone. I know how much it does.
Yeah, so as Vincent was mentioning early on, so we have 3 test labs that are capable of certifying the boards. It depends on how much effort is required to do so, actually. So I don't think they are charging by the hour, but they are neither charging by boat. But you can roughly get 5,000, something like that, from 5,000 to 10K, if you like. That's a good enough. Yeah. That's roughly, yeah.
And the other one, so basically you answered that part earlier as well, how much time it needs? Because I see that there are vendors like Pine64, for example, who provide SPI flash on board for firmware, etc., and they don't even bother with putting anything else there, because user will take care of it.
Yeah. The ACS itself it depends on the board. On the Sync-Acer, which I have results, which is an A53, because keep in mind the majority of the tests run in EFI. It doesn't matter how many cores you have, right? It takes something 4 or 5 hours, something like that is the average. And it spins up a Linux instance, which depending on how many cores you have, it goes faster. But it's not a huge amount of time spent in Linux. The majority of time is spent in the EFI firmware.
Maybe to continue on the answer, the runtime of the ACS is not the major time consumer. For some systems, it took more than a year working with the partner to figure out what they needed to do in their BSP, what they needed to do to upstream to the kernel and then to the distros.
And this is the time I was asking.
Yeah, that's okay.
Because I'm running some parts of ACS, I run BSA, ACS, SBS, SCS, etc. on SBSA reference platform, so those tests take time. They generate insane amount of logs, which sometimes are hard to go through. So yeah, but I was more interested how much time it takes in real examples, right? So you told it can be different.
That's the worst case I was mentioning here. In the best case, it's less than a month when the customer is starting from a sane basis, coming from the SIP with the reference design and BSP. Upstream support in the kernel and distro is there already from the SIP, and then collecting the results when everything goes well and nothing was broken during OEM integration and all. It's really smooth in that case.
If your starting point is UFI, so obviously your baseline is there. But if your starting point is something completely different, is when you go to this 1 year. And this is where, if you remember, so the graphs from Vincent is the amount of time we spend and where ARM is involved. We are very much involved there during that period of time, telling them what's failing actually, what is the reason for failing, what they have to change, actually reviewing the code, and that takes a huge amount of time. Yeah.
So, Elise, I wanted to go back to one of the points you made about the OS installer not having all the drivers. That was another big issue I ran into. I didn't have time to cover. The issue isn't getting the drivers upstream. All our drivers are upstream. The issue is then who do you work with on the distros to make sure that then they enable those drivers in their installers by default.
So it's easy for us to work with Red Hat. They remember I just
and by the way, I missed calling out. Red Hat is the best distro for an embedded device to work on. I want to give them kudos. But
you mean Fedora?
Fedora. So if you look at Fedora,
Correct.
if you look at the list of certified boards, Fedora is the majority of OSs that we use to certify, right?
So that was not the problem. It's the other ones that I ran into.
Exactly. So here's Peter. We were just saying how much of a good job Fedora is doing in promoting SystemReady and adding drivers, and we can't get the rest of the distros to do that. Yeah. Perhaps one. I mean.
I figured that was going to be.
Can you have like 6, 7 different flavors? Fedora 1, 2, 3, so we can use it to certify. So one potential solution there would be to work with ARM and enable OpenWRT or Yocto releases, potentially Buildroot. I don't know what ARM is willing to accept, right? But if you could have a vertical integrated distro that you control the configuration and the kernel, at least on the public side, and you make sure that your drivers are enabled in the monthly releases or bi-weekly releases or nightly builds or whatever they do, that would be easier to get certified. I'm not talking about downloading Buildroot and building a TI-specific distro. I'm talking about using the generic ARM64 image for Buildroot for certification. That would make at least getting the features in the kernel you want faster. That's fine.
Thanks. That's fine. For OpenWRT specifically, so now it's a recommended distro since SRS 2.2, and there is a pre-built ARM64 image on OpenWRT website, which can be used for certification.
Oh, Bill.
I think the straight answer to John is also to consider Debian, because they at least do everything in public and you see how it's done. As in, you can follow the prior art. It's slightly baroque in places, but you can follow the prior art because it's public. So it's another good one to target. And it's usually just a bug report that you've got to write. You've just got to figure out which options you want them to turn on, and ideally have tested it before you tell them what to turn on.
Still easier for me on Fedora. I just mail Peter, say, can you enable these, please?
In most cases, I already have it in my to-do list.
I was going to say much the same thing. If the goal isn't to pass the test, the goal is to have it just work, as John said, right? So that has to include Debian. And so
I agree. I think we should be working with distros now. Jokes aside, we should be working with distros, and we should be getting board support proactively up there before the board is even released or passing the system-ready certification.
And if you have drivers that you need enabled in the Yocto generic ARM64, talk to me.
Yeah, obviously.
I mean, ultimately, I think the silicon vendors should be working with the distros to enable their drivers to ensure things just work. So it shouldn't be a Linaro job or an ARM job. It should be the silicon vendor's job.
It should start from somewhere, though, right? We should teach
Correct.
them that, proactively, before you add the board, before you go to pass the certification, please enable everything on the distro so you won't get 6 months delays.
Yeah, like my general rule of thumb for an enabling thing is, I want 3 or 4 people to actually want to use the device. But I had one silicon vendor open a ticket and go, oh, I can't do this. Can you enable, the kernel starts to boot and the serial output stops. And I went, yeah, because we don't enable your platform. And they're like, oh, why not? No one's ever asked for it. I don't have anyone testing it. So if you want to, test and continue to test and work with me to make sure it works, I'll quite happily enable it. And I went through the driver list. I have a terrible, terrible bash script that basically greps all the compatible strings in a device tree and then maps that into the compatible strings in the driver and tells me the code configs I need to enable.
I have news for you. There's a kernel self-test that was merged 4 months ago, which does that.
Well, but I was doing that 5 years ago.
Yeah, you can now use, upstream stuff.
Ugly upstream bash scripts instead of my own ugly bash script. But yeah, so there's things like that where when I get a request, it's really simple, and Fedora in particular rebases its, so we'll land it into Rawhide, and as soon as that config is merged, essentially 2 days later, because the config will be merged, the kernel will be built, and then the whole thing will be composed. So basically 2 days later, people can go and start playing, and the silicon vendor was shocked at how quick it was. And luckily with the community stuff, it's much more straightforward than an enterprise distribution where there's support life cycles and customer demand and other things that need to be taken into account.
There's another talk, relevant. Pere is giving one in a few. When is it? Thursday, right? Yeah, we have a talk on Thursday about other missing features.
Right? This is the one we're all doing.
Yeah. So if anyone's interested about what we found on a recent workshop we did about gaps that we want to fill in and fix properly, or most importantly, if you have input of things that are missing from the open source ecosystem for the support, please join that one and give us feedback.
I have one question. Not question, but I don't know the SystemReady in detail, but where does it start? It starts from U-boot, UEFI, or it goes further down?
No, it doesn't go further down. There's no secure world mandates, there's no PSA mandates from ARM or anything regarding to anything prior to BL33.
Okay, yeah, thank you.
Well, and it doesn't even really mandate U-boot. That's just a reference implementation.
U-boot is just the only reference implementation that supports device tree. That's the situation where
Tianaco does.
Well, yeah, but not all the boards. I mean, yeah, I know, but not for the boards that we try to certify in IR.
Yeah, but you can use Tianaco as well. And there are vendors that have system-ready capable devices that are Tianaco based.
The Raspberry Pi got ES certified, though, because they're doing ACPI with EDK2. Oh, they did both?
Yeah, except it's a joke certification, because with the ACPI mode, you don't get any of the graphics or GPIO or other useful things that the board provides.
That's IR1X certification, which was not testing for Ethernet or
Of course.
advanced.
I would actually just like that toy certification to go away, because it's not even dealt with by the vendor themselves.
It's deprecated now.
Good. Anyone else?
So speaking of security, so you mentioned UEFI variables can be stored in a file or an RPMB currently in U-boot today. Does SystemReady or the ACS require anything related to that?
If you try to run the security interface extensions, it is required.
Is required what?
To be able to read and write variables.
No. My question is it required that it be an RPMB versus on a file?
No.
Okay, either one will pass all of the SystemReady tests.
The security requirements won't pass the SystemReady testing of reading and storing variables will work in either a file or an RPMB. If you want to pass the security requirements, you need an RPMB at the moment.
So the SIE extensions were...
They don't require an RPMB. The implementation, the only working implementation we have right now in U-boot is an RPMB.
It requires secure variable storage, and storing them directly on a file system is insecure, so it fails because of the security.
You can use a secure SPI flash, right? We just don't support it in U-boot.
Yeah.
The only working.
U-boot will refuse to persist the authenticated variables in a file currently by default. So normally there is no way you can do a broken system willingly. Well,
we will actually store it, right? We will refuse to load it.
Oh yes,
because you could hack the file and add your variable, right? So we refuse to load any authenticated variables from a file because it's against what the IFI spec mandates for storing and reading secure variables.
Okay, so all of the SIE tests that require you to enroll keys won't find those keys if they're stored in a file.
Exactly.
Okay. And so it fails.
You could implement any secure storage. The actual implementation that's working in U-boot right now is only the RPMB.
Okay. So only boards with eMMC, really?
Yes.
Okay.
There was someone that did post patches around storing them in SPI, but I don't think that was actually secure.
No, it wasn't. You need an isolated flash. That's the whole point, right? You need an isolated flash with... The EFI spec is quite clear. It says I need a flash with rollback protection and tamper protection, so the SPI isn't one of these. You could, in theory, put a SPI flash in the secure world and implement your own encryption to protect the variables. No one has done that, but you could do that.
This last one. You mentioned about TPM. Is it mandated that any TPM, like firmware backed or hardware backed?
Anything works. We have discrete TPMs, we have firmware TPMs, and we even have QMU with a software TPM running the certification. So. Yeah, TPM 2.0.
Yeah, it requires to be version 2.
Okay.
It is optional.
Yeah. Thank you.